welcome to limiting reactant stoichiometry problems number 2. As usual, you need a periodic table and a calculator for these items here. We also want to make sure that you understand your three understandings of the mole. Moles equal mass over formula weight. Moles equal molarity times volume in liters. Moles of a gas at STP is equal to volume in liters over 22.4. You want to make sure that you have that written either on the back of the periodic table or in your mind. So we're ready to go. Let's jump in with number 1. The first thing you always want to do is you want to look at an equation and see if it's balanced. So if you have not balanced it yet, pause the program and give it a balance. All right, to balance this, we need a 2 here. The second step in limiting an excess stoichiometry is you want to make sure you have everything that you've been given and put it into moles. So I would say if you haven't done that yet, pause the program and put all of your given information into moles. All right, so the question here says, what is the maximum mass of CaSO4 that can be prepared when I have 24 milliliters, I'm going to turn that into liters, 0.024 liters, of a 0.34 molar potassium sulfate solution, and I have 0.047 liters of a 0.1 molar calcium chloride solution. So I need to get moles of both of these. These are both solutions, so I'm going to take the molarity and multiply it by the volume in liters to get those. And then now comes the fun part. I have to figure out which is my limiting reactant. That's step 3. So in a perfect world, this is a 1-to-1 ratio. I would have exactly the same amount. So I'm going to cover up one number. Doesn't matter what number I cover up. This is a 1-to-1 ratio. So if I have 0.0082 moles of this, I should have 0.0082 moles of calcium chloride. Let's take a look. Do I have 0.0082 moles? No, I actually have less than I need, so this is my limiting. You could go the other way and say, hey, I need 0.0047 moles of this, and you would look and you would say, oh, look, I have more than I need, so this is excess. Okay, so either way, you're always going to get to the same number. So now we have our limiting. The last step in our stoichiometry process says you take your limiting, and that controls your stoichiometry. So now I know how my limiting is my calcium chloride, and I want to get to my target, which is calcium sulfate. So I'm going to go 1-to-1. So that means that I have 0.047 moles of calcium sulfate. And it wants to know, though, it says, what's the maximum mass? So I'm looking for grams. So I'm going to set that equal to X over 136, which is the formula of 1 calcium, 1 sulfur, and 4 oxygens. So you get 0.64 grams of calcium sulfate. Awesome. So hopefully you warmed up. Let's give it a try for number 2. Balance it, put it into moles, identify limiting, and then answer the question. All right, to balance, we're going to put a 2 here. And the question says, what is the maximum mass of sodium carbonate that can be produced from 15.2 grams of solid sodium hydroxide here, and it's mixed in a balloon containing 9.63 grams of carbon dioxide. Now, I got to get both of these into moles, so if you haven't done that yet, pause the program, get moles of each of these. All right, so hopefully you took your 15.2 and divided by 40, which is the formulate of sodium hydroxide, and got 0.38 moles of NaOH. Then I also am going to take my 9.36 divided by the 1 C and 2 oxygens, which gives me 44. Now we're going to take a look here, and we're going to talk about which one is our limiting. Again, I personally like to multiply, so we're going to go from here to here, from 1 to 2. So I'm going to cover this number up, and I'll say for every one of these, I need 2 of those. So if I have 0.22 of these, multiply by 2, I should have 0.44 moles of NaOH. So this number should be 0.44. Let's take a look. Is it 0.44? No, it is not 0.44. I actually have less than I need. This is a hypothetical number. This is what I should have to react with all my carbon dioxide. So I do not have enough, so this is my limiting. We said the last step is that you take your limiting and you proceed with your stoichiometry. So now I know that the sodium hydroxide is my limiting, and I'm trying to get to my sodium carbonate mass. So I'm going to say this is a 2-to-1, divide this number by 2. Now I have moles of Na2CO3, and I want mass of Na2CO3, so I'm going to X over 106. 2 sodiums, 1 carbon, 3 oxygens. You get 20.14 grams of Na2CO3. All right, pause the program, give a try to number 3. All right, to balance number 3, we're going to put a 2 here and a 2 here. Oh, my numbers are falling down. Beautiful. And if you read, it says, what is the maximum mass of CaF that will form if I have 2.8 grams of calcium nitrate and I have 260 milliliters of a 0.1 molar Kf solution? So again, you want to get moles of both things. So if you have not done that yet, you really want to start trying to do some of this stuff by yourself. To get moles of calcium nitrate, I'm going to take my amount, 1 calcium, 2 nitrogens, 6 oxygens, gets me a formula weight of 164. When you divide that, 0.014 or 17, excuse me, moles of calcium nitrate. This is a solution, so I'm going to multiply molarity times volume, but it's got to be in liters. So I'm going to change that. When I do that, I get 0.026 moles of Kf. Now, you could go either way you want. I'm going to go from a 1 to 2 ratio. This is a 1 to 2 ratio, so I'm going to cover this up. So for every one of these, I would need twice as much. So I'm going to take this number, and I'm going to multiply it by 2. And what I should have is 0.03 more moles of Kf, 0.034. Do I have 0.034? The answer is no. I actually have less than I need, so this is my limiting. Now, we take what we have as our limiting, and we're going to answer our question. So Kf is my limiting, and I want to go to CAF. That is a 2 to 1. So I'm going to divide it by 2, and that's moles of CAF. But the question here wants to know mass of CAF. So I'm going to multiply that by 78, which is the formula of 1 calcium and 2 fluorines, and I get 1.01 grams of calcium fluoride. On the back, we have a couple thinkers. Let's take a look at number 4. Consider the following acid-base neutralization reaction. If 38.3 milliliters of 0.5 molar H3PO4 is mixed with 1.68 grams of sodium hydroxide, will the final system be acidic or basic? So I think you should pause the program now and see if you can't figure out the answer. All right, if you didn't pause, or you paused and you have no idea where to start, I guess my question would be here to kind of give you a little hint. What is the excess? What would be your excess here? Think about it, and again, if that's enough to get your mind going, pause it again, and let's see if you can't get this figured out. All right, hopefully you tried this. Let's see. First of all, we got to balance this equation, so I want a 3 here and a 3 here. You know that you have 0.838 milliliters of a 38.3 milliliters of 0.5 molar acid solution, and you have 1.68 grams of your base. In any limiting in excess, we want to figure out, okay, our moles of H3PO4. I'm going to multiply my molarity times my volume, turn it into liters, and I'm going to get 0.019 moles of H3PO4. When I have my solid, I'm going to divide it by its formula weight, which is 40 of NaOH, and now I have moles of NaOH. Now let's take a look. I'm going to cover up this one because I like to multiply. This is a 1 to 3. You could go the other way, but we're going to go 1 to 3. So for every one of these, I need 3 of these. So if I had 10, I need 30. If I had 20, I need 60. So I'm going to take this, I'm going to multiply it by 3 to see, in theory, how much I should have. So I would need 0.057 moles of NaOH. Do I have 0.05 moles of NaOH? That's a no, okay? This is my limiting. And so think back to the demonstration. If it's my limiting, that means I'm going to use it all up. This is going to be my excess. That means that's going to be left swimming around. So the question here says, is the final system acidic or basic? So if I have extra acid flying around in my system here, okay, the excess is acid, so therefore the solution should be acidic when the whole reaction is done, because I used up all of my base and I have leftover acid. All right, number 5, read the problem, balance it, try to figure it out. All right, a student cuts a 20-centimeter length of aluminum wire and measures its mass to be 0.819 grams. What will be the final mass of the aluminum wire after I have 15 milliliters of a 1 molar hydrochloric acid solution react with it? And we also balance the equation. Good. If you don't know anything else, put everything into moles and see what you can go from there, because this is a thinker. All right. So in order to find moles of aluminum, I'm going to take the mass of aluminum divided by 27. I get 0.03 moles of aluminum. And then I'm going to take for moles of my hydrochloric acid, I'm going to take the molarity multiplied by the volume, make sure it's in liters, and then I'm going to get moles of HCl. Let's take a look and see what might be limiting, what might be excess. So I'm going to cover this up. This is a 2 to 6 or a 1 to 3 ratio, so I'm going to multiply this by 3. 0.09 moles is what I need. Okay, I absolutely do not have enough. 0.09, 0.01. This is not enough, so this is my limiting. Now, I want you to think about that. That means all of this is used up, and this is going to be my excess. Can you figure out how much of this I'm going to use? And then how much of that is going to take away from my starting wire? That is a thinker. Pause the program, see if you can't figure it out. All right, so let's go here. Can't figure it out, let's do this one. The next one's pretty much exactly the same, so hopefully you can figure it out. So if I use up all of my hydrochloric acid, that is my limiting, so I'm going to use it all. How much aluminum is this going to take with it when it goes away? So I have a 3 to 2 ratio. I don't know how much aluminum is going to be eaten away from the wire in the reaction. So I got a 3 to 2, or 6 to 2, or 3 to 1. So I'm going to divide this number by 3. Now, I have 0.005 moles of aluminum that are going to be used. At any time, pause the program and see if you can't figure this out yourself. So now there's a few actually ways you can do this. I'm going to do kind of one of the most common ways. If that's how many moles of aluminum I use in the reaction, and I'm going to figure out, multiply it by 27 to figure out how many grams I'm going to use. So if I sharpened a pencil and I took this many grams off of my pencil that had this mass, how would I know my pencil at the end? Well, if this is my mass of my grams of aluminum to start with, and this is the mass that I used, hopefully you have 0.684 grams of aluminum left at the end. I would say number 6 is almost exactly the same, so absolutely pause the program here. See if you can't figure this one out on your own. All right, let's balance this equation. We're going to put a 2 here. A student places a shiny piece of 1.49 gram zinc metal into a test tube that has 8 milliliters of a 1 molar hydrochloric acid solution. After the reaction is complete, what is the predicted mass of the zinc piece? So again, I'm going to put my moles of zinc. I'm going to take my mass of zinc over 65, which is the formula weight of zinc. Then I'm going to do my molarity times my volume in liters, make sure it's in liters, and now I have my moles of hydrochloric acid. This is a 1 to 2 ratio, so I actually need twice as much of this as I do here. It's clearly not going to happen. This is my limiting, so this is what I'm going to use up. Again, if you just watched number 5, can you go from here and tell me what the mass of the zinc piece is going to be at the end? All right, so I'm going to take my moles of hydrochloric acid to go from hydrochloric acid to zinc and figure out how much is going to be used. I'm going to do 0.21. I'm going to divide this by 2, so 0.004 moles of zinc is used. Again, pause at any time. If that's how much zinc I have used, let's turn that into grams that I'm going to react away. And if I started with 1.49 grams and I used 0.26 grams, Your zinc at the very end should be 1.23 grams. All right. Thank you very much. Bring any questions you have into class.